This video shows you how to hang acoustic panels on the wall. Firstly, make sure that you're not drilling perpendicularly or at right angles from sockets or switches. Also, do not drill 150mm from the corner of each wall, where one wall meets another or the joint between two walls. So basically, do not drill 150mm from the corners of both walls and 150mm from where the wall meets the ceiling. These are your electrical safety zones. So I've gone further to use a stud finder to map out stud locations lying concealed beneath the wall. So wherever the Franklin sensor stud finder illuminates red, I have marked out points on the tape which is on the wall. Preference would be to drill at the center. Studs are about 1.5 inches, so if I get 3 LED points on the sensor, it could possibly connote that we've found a stud location. Okay, studs are generally placed 16 to 24 inches apart, center to center. And you can see where I've taped out electrical safety zones at 150mm, so I don't go past that mark when drilling through the wall. Okay, and you know, from the wall corner, okay, so it's 150mm from the corners and from the ceiling, and vertically or horizontally from sockets and switches. Okay, these are your electrical cable safety zones when concealed inside walls. You can also locate a stud by, tapping your knuckle on the wall and finding out areas that's more solid as opposed to hollow. If it's not hollow, then it could indicate that you've got a stud there. And as you can see, using a stud finder makes the job a lot easier. When I move the stud finder, the LED red point moves with the stud. Okay. And as highlighted previously, 3 LED points could indicate a stud location. You could also get studs that illuminate on more than 3 LED points, but it's just a lot safer to drill through 3 LED points, which indicate 1.5 inches. And as you can see on this 3 LED point location, I will be drilling through the center if I decide to hang the acoustic panel on that particular stud. And you can see, I'm identifying more stud locations. And also, if you get more LED points lighting up, it may necessarily not be a stud. It could be foil, it could be metal, a plastic pipe, a metal pipe, the list is endless. So the way to get around this is to first map out the entire stud locations using the Franklin's sensor with a pencil and a masking tape. Then subsequently, identify the most probable or plausible stud locations where you'd like to hang your acoustic panels on. So in my case, I have identified my preference by marking out 3 points on the stud location and marking out, the center offset from both edges, which will help to forestall the incidence of drilling very close to the outer edges. Sometimes there are incidences where cables cannot be run in the electrical safety zones, and as such may encroach in the non-electrical safety zones. Suffice to say, when you're drilling in an area where you shouldn't have cables, you might just as well meet a cable. And that's where your Truvo multi-level surface pipe and cable metal detector comes in handy. It's used in detecting metal, pipes and live cables. If it latches or catches onto a metal component, it flashes solid red. As it approaches a dense material or metal object, it turns from solid green to yellow and then to red or flashing red. If it's flashing red, it's detected a live cable, and if it's solid red, then it's detected a metal object or dense material. For an in-depth or incisive exposition on how to use the Franklin sensor and the Truvo multi-level surface detector, as well as how to calibrate the Bosch multi-level surface detector, click on the link in the description. So, based on the extrapolations from the Franklin's sensor and the Bosch multi-level surface detector, I can deduce that I haven't really got, live cables or metal components in conjunction with the wooden stud, and that's because when I hover the multi-level surface detector, it remains green. It doesn't turn red or flashing red, except when it's quite close to sockets and switches. which is, within the electrical safety zones. It is important to take cognizance of your wooden stud locations, as well as where you've got metal cables embedded or live cables, as you do not want to be drilling in blindly. You could hit a live cable, you could burst the water pipe. The list is endless, and this could accumulate or result to costly repairs, be it cosmetic or an incisive rework or repair that needs to be done. Do note that if you're detecting incidences of electrical cables in the non-electrical safety zones, it is still possible to run cables in these zones as earlier highlighted, so far as guidelines are followed. And so this is a non-electrical safety zone, and I'm detecting live cables there. And so the guideline says that the cable must be over 50 mil below the surface. If the wall is made from metal, then it needs RCD protection. The cable should be armoured with an earthed armour or metal sheath. The cable should be in a metal trunking or conduit which is earthed, or it should have protection from at least 3 mil steel. So if I happen to drill through in the non-electrical safety zone, I shouldn't be expecting to hit any metal plate, covering any live cable. It must be over 50 mil below the surface, and so that should give you a rough idea of the kinds of wall plugs and screws you should be using, or your drill bit. It shouldn't be over 50 mil. You shouldn't be drilling way above 50 mil, and your plug or screw should just be under 50 mil. If there is a high incidence that you might hit a cable or a metal plate that's been latched onto the wooden stud to protect them cables. So make sure that you measure, from the floor to where you'd be placing your eye hooks, to hook the acoustic panels. Make sure that they're centralized and visually inspect them to make sure that aesthetically it is what you want. Mask your drill bit, make sure it's, aligned with your plug so that you do not drill too deeply further through the wall. So here I will be using a 5.5 mil drill bit to open up the hole, and then subsequently push fit the 6 mil plug flush against the wall with the aid of a hammer. The next step of the process would be to insert or install the plug flush against the wall. Then subsequently replicate the process for the other stud hole location. The next step of the process would be to select the appropriate open eye hook. The plug is 6 mil, and so you'd need to select an eye hook that fits perfectly into the plug prior to installation in the fitted wall plug that's been installed on the wall. Replicate the process for the other wall plug as well. So we've got 2 points that we would want to mount the acoustic panel on. Okay, and here you can see that I'm screwing in the open eye hook into the other hold position. The final step would be to install both acoustic panels, and you can see that the hanging wire has been run at the back through 2 D-rings. So if you want to see how to install the hanging wire, click on the link in the description. Make sure that the hanging wire isn't straight, just give it like a thumb clearance from the center, and then hang it onto the eye hook that's been installed on the wall. This will enable the burlap or the backing of the acoustic panel to breathe, as improving the quality of sound in the room has a lot to do with mass and space. And as you can see, both acoustic panels have been installed with no hitches, no impediments, no burst pipes, no live cables, and they have been centralized aesthetically just as I want them. Suffice to say, preparation is crucial to any job, and you can see the gap behind the acoustic panels where I would want the panels to breathe. Also replicated in the other panel to the 9 o'clock position, and I have replicated this process for hanging acoustic panels on the ceiling. Taking cognizance of the electrical safety zones, the exceptions, when live cables are run through non-electrical safety zones, using the metal stud finder or the live cable finder and wooden stud finder to locate stud positions around the landing area. So here I have used a combination of closed eye hooks and a carabiner snap hook, when trying to fit acoustic panels in the 12 o'clock position. if I use both carabiner snap hooks, the acoustic panel will tilt slightly due to gravity and also due to the angle of play around the closed eye hook and the snap hook. So, to restrict the movement, on one end I will be using the carabiner snap hook and the closed eye hook, and on the other end I will be using an open eye hook to restrict the angle of play on the D-ring that's fitted at the back of the acoustic panel. And here you can clearly see the carabiner snap hook that's been installed on the closed eye hook, and on the other end you can see that the D-ring has been installed on the open eye hook. And if you twist the open eye hook to the 3 o'clock position, it helps prevent, a lot of play with regards to the acoustic panel tilting to one side. So tweak it bespoke to your requirements as long as it impedes a lot of play or tilting of the acoustic panel. And you can see that I've replicated the process for other acoustic panels, at the 3 o'clock position and the 9 o'clock position on the walls, okay? Click on the link in the description on how to build acoustic panels, bass traps, reflection-free zones, and how to hang your picture frames, and as well as how to improve the sound quality in your studio or room. And that's about it really. If you found the information useful, don't forget to subscribe, like and share. Helps the channel grow, and hopefully catch up with you later. Thank you for your time, thank you for listening, and goodbye.